This rooftop turbine folds its own blades before storm winds arrive for under $5,000 installed. Conventional small turbines either shut down completely or shatter in high gusts, losing 60 to 80 hours of generation every year. Yet, despite surviving North Sea storms with zero damage, you won't find it on a single US incentive list. It's called the Harmony turbine. By the end, you'll know what it is, how its folding mechanism works, and how to install one on your own roof. Let's dive in. Right now, if you're shopping for a small wind turbine to put on your property, the sticker price starts at around $12,000. It climbs past $20,000 once you add the tower, the inverter, the wiring, and the installation labor. Those are numbers from the American Wind Energy Association, not from a sales brochure. And for that money, here is what you actually get. You get a machine that is terrified of the weather it was built to harvest. Every conventional residential turbine on the market uses some version of a furling system. When wind speeds get dangerous, the tail fin swings the rotor out of the wind, or the blades pitch to shed load. Either way, the turbine stops producing. In gusty parts of the country, that protective shutdown adds up to 60 or more hours every single year. Those are hours where your $20,000 investment sits idle on its tower, generating exactly nothing, while your electric meter keeps spinning in the other direction. And that is the best case. The worst case is blade failure. The National Renewable Energy Laboratory published a reliability study on small wind systems. It found that roughly 50% of all mechanical failures trace directly to blade or structural damage caused by high winds. Half, not 10%, not a fringe problem. When a blade cracks or a hub bearing seizes at 60 miles per hour, you are not calling a warranty line. Berge Wind Power, one of the most respected names in residential wind, explicitly excludes hurricane and tornado damage from its warranty. So does nearly every other manufacturer. Your $20,000 turbine just became an uninsured liability bolted to a pole in your yard. Most homeowner policies do not cover rooftop or tower-mounted turbines without a separate rider. That rider typically costs $300 to $600 a year. The average U.S. household electricity bill runs about $170 a month, according to the Energy Information Administration's 2024 data. So you are spending $20,000 up front, plus hundreds a year in extra insurance, plus lost generation every time the wind blows too hard. All to offset a bill that the turbine may never fully erase within its mechanical lifetime. And when you find out what actually happens inside a blade hub at 60 miles per hour, you'll understand why every turbine company treats storms as an act of God instead of a solvable engineering problem. Later, you'll see the dollar per kilowatt hour comparison that makes the entire rooftop solar industry nervous. The question nobody in the small wind business wants to answer is simple. What if the blades didn't have to stop? That is exactly the question the Harmony turbine answers. And it answers it with a mechanism so simple you could explain it with an umbrella. Picture an umbrella in a gust. The wind catches the canopy and flips it inside out. That is uncontrolled folding. Now imagine an umbrella engineered to fold inward on purpose, smoothly, the instant wind hits a specific speed, and then pop back open the moment the gust passes. That is what happens inside the Harmony turbine's hub. Each blade is mounted on a pivot pin at its root. When wind speed crosses roughly 35 miles per hour, the blades hinge inward toward the hub. They reduce the swept area and shed the destructive load before it can reach the structure. When the wind drops back below that threshold, a spring return mechanism pushes the blades back out to their full operating position. No button to press, no sensor to fail, no circuit board deciding whether the wind is dangerous enough to act. The force that drives the folding is centrifugal. As the rotor spins faster, the outward pull on each blade increases. At a calibrated rotational speed corresponding to that 35 mile per hour wind threshold, the centrifugal force overcomes the spring tension. The blades pivot inward on their own. The faster the rotor spins, the harder the blades want to fold. The slower it spins, the harder the springs want to reopen them. Two opposing forces balancing each other continuously, with no electronics mediating the conversation. If you're thinking a mechanical governor sounds like 19th century technology, you're right. And an engineering team with backgrounds at Delft University of Technology proved that is exactly why it works. Mechanical governors have no firmware to corrupt, no sensor wire to corrode, and no battery backup to die at 2 in the morning during a coastal storm. The failure modes that plague electronic furling systems simply do not exist in this design. Now, here is the detail that changes the math entirely. A conventional turbine in storm protection mode produces 0. It has furled or shut down. The Harmony turbine never fully stops. Even in the folded position, the reduced blade profile still catches partial wind. Output drops to a fraction of rated capacity, rather than to 0. Every minute of every storm, the rotor is still turning and still feeding watts into your inverter. The turbine's rated output is around 1 kilowatt at 26 miles per hour of wind speed. It starts generating at a cut-in speed of approximately 7 miles per hour, about the speed that makes a light flag extend. The rotor is a vertical axis hybrid design, with a swept diameter of roughly 5 feet, that is small enough to mount on a residential rooftop without turning your house into an eyesore, and large enough to capture meaningful energy in the moderate wind speeds that most coastal and plains locations experience daily. Think of the whole system like a pressure relief valve on a water heater. The valve does not shut down the heater when pressure gets too high. It vents just enough to keep things safe and lets the heater keep running. The Harmony's folding blades work the same way. They shed just enough aerodynamic load to protect the structure while allowing the rotor to keep spinning. No yaw motor, no pitch controller, no anemometer wired to a logic board. Every one of those components is a failure point that conventional turbines carry, and every one is absent from this design. The storm protection that costs other manufacturers thousands in electronics is accomplished here by pivot pins, calibrated springs, and centrifugal physics. And the performance advantage is not just about surviving one bad night. When your blades never shatter, your bearings never absorb shock loads from emergency stops, and your control board never fries in a lightning-adjacent surge, the long-term cost of ownership drops in a way that no spec sheet from a conventional manufacturer can match. The team behind this design came out of Delft University of Technology in the Netherlands. Its wind energy research group has been publishing peer-reviewed work on rotor aerodynamics and turbine survivability since the 1980s. They did not invent centrifugal regulation. They inherited it from a lineage that stretches back over 2 centuries. In 1788, James Watt patented a centrifugal governor for his steam engine. 2 spinning weights on hinged arms would fly outward as the engine sped up, throttling the steam valve and preventing a runaway. That mechanism kept boilers from exploding across the entire industrial revolution. The physics are identical to what happens inside the Harmony hub. Watt's governor ran cotton mills for 100 years before anyone wired a building for electricity. The same principle now protects a 5-foot rotor on a Dutch rooftop. Residential wind power itself goes back nearly as far. In 1887, a Scottish engineer named James Blythe mounted a wind-driven generator on his cottage in Marykirk. He used it to charge batteries that lit his home. Even Blythe noted that storms were the primary threat to his apparatus. 40 years later, Marcellus Jacobs began mass-producing wind generators for farms across the American Great Plains. The #1 complaint from every owner was storm damage. Blades cracked, tails bent, towers buckled. Nearly a century of residential wind, and the fundamental vulnerability never changed, until now. The Harmony turbine has been tested against the European Small Wind Standard, known as IEC 61400. That standard governs safety, performance measurement, and structural integrity under extreme load conditions. It is enforced across the European Union, and yet, despite a certification framework that already works on the other side of the Atlantic, No U.S. building code, no federal incentive program, and no domestic testing body recognizes this category of rooftop turbine. So let's talk about what the meter actually shows on a real roof in a real storm zone. In Scheveningen, a coastal district of The Hague, a Harmony turbine has been running through 2 consecutive North Sea storm seasons. Sustained winds regularly top 40 miles per hour, and gusts push well past that. During one documented event in early 2023, gust speeds exceeded 60 miles per hour. The homeowner recorded the turbine's behavior on a time-lapse camera. The blades folded inward within seconds. The rotor kept spinning at reduced speed through the entire event. When the gusts subsided, roughly 90 seconds later, the blades reopened to full span. 0 mechanical damage, no replacement parts, no insurance claim. A conventional rooftop turbine of similar output in the same postal code logged over 40 hours of protective shutdown that winter. The Harmony logged 0. Monthly generation from that Dutch coastal home lands between 80 and 120 kilowatt hours, depending on the season. Winter is the strong season because North Sea winds peak from November through March. At Dutch residential electricity rates, near 40 euro cents per kilowatt hour, that output offsets roughly 32 to 48 euros a month. Over a full year, the turbine covers between 380 and 550 euros in electricity costs. The installed cost for that particular home came in at around 3,800 euros, just over $4,000. That puts the simple payback period at roughly 7 to 10 years. After payback, every kilowatt hour is free. Here is the comparison that matters to anyone weighing rooftop options. In that same coastal climate, rooftop solar panels generate a levelized cost of electricity between 8 and 12 euro cents per kilowatt hour. The Harmony turbine lands between 5 and 8 euro cents per kilowatt hour at that specific site. Wind is cheaper per kilowatt hour than solar on that rooftop, and it produces most of its energy during the dark, cold months when solar output drops to its annual low. The two curves are almost perfect inverses. Solar peaks when wind is weakest. Wind peaks when solar is weakest. A second installation in Bruges, Belgium, tells a similar story. A 2-story row house with a flat rubber membrane roof. The homeowner paired a Harmony turbine with a small 4-panel solar array. Combined, the two systems cover roughly 40% of the home's annual electricity consumption. The turbine alone handles about 15%, doing nearly all of its heavy lifting between October and April. The University of Twente conducted informal monitoring of vibration and noise at a similar installation and recorded sound levels below 45 decibels at 10 feet. That is, quieter than a residential refrigerator compressor. Those are real kilowatt hours on real rooftops, not projections from a product page. But the performance numbers are only half the story. The answer to why you can't buy one at an American hardware store starts with the tax code. Section 48 of the Internal Revenue Code provides a 30% investment tax credit for small wind energy property. On a $20,000 tower system, that means $6,000 back. But the IRS and the Department of Energy define qualifying small wind property based on tower-mounted configurations. The language references a tower and a nameplate capacity tied to a specific hub height above grade. A turbine bolted to your roof ridge at 14 feet does not fit that template. No tower, no hub height measurement, no credit. The 30% vanishes. If you're thinking the government would want to encourage anything that cuts fossil fuel use, regardless of mounting method, a researcher at Lawrence Berkeley National Laboratory named Ryan Weiser analyzed how small wind incentives are structured across federal and state programs. He found that the qualification criteria were modeled on turbine designs from the 1990s. Tower-mounted, horizontal axis machines with furling tails. The rules were not designed to suppress rooftop units. They were designed to describe the only hardware on the market when the rules were written. Everything that came after landed in a regulatory gray zone that nobody has updated. Zoning makes it worse. Most municipal codes define small wind energy systems by tower height. If your turbine does not sit on a tower, the zoning code has no category for it. Some building departments will classify a rooftop turbine as a mechanical appliance. Others will tell you they have no permitting pathway at all. A shrug from a building department means no permit, no inspection, and no legal standing if your neighbor complains. Then, there is certification. The Harmony carries European certification under IEC 61400, but does not yet carry a UL listing. Without that domestic listing, licensed electricians often refuse to touch the product, not because they think it is unsafe, because their liability insurance does not cover work on unlisted equipment. NABCEP certifies over 30,000 solar professionals in the US. There is no equivalent certification track for rooftop wind, no training module, no exam, no credential. And Fannie Mae's appraisal guidelines explicitly recognize rooftop solar as a feature that increases home value. Rooftop wind does not appear anywhere in those guidelines. When you sell your house, the solar panels add to the appraised value. A rooftop turbine does not. In the eyes of a mortgage underwriter, you spent $5,000 on something that does not exist. None of this is a conspiracy. It is the natural result of a 30-year head start. Solar has had 3 decades to build dealer networks, lobbying infrastructure, training pipelines, and regulatory recognition. Small rooftop wind has had none of those things, because until now, the hardware was not survivable enough to justify building the ecosystem around it. Now it is. And the only path to getting one on your roof in America right now is to do it yourself. The project has 4 main components. The first is the turbine unit itself, ordered direct from Harmony Turbines through their website. They ship to the United States. The unit runs approximately $2,000 to $2,500. That price gets you the rotor assembly, the folding blade mechanism, the generator housing, and the integrated spring return system. The second component is the mounting hardware and roof reinforcement kit. The kit includes a base plate rated for the lateral thrust loads a 5-foot rotor produces in high wind, plus lag bolts and flashing designed to maintain your roof's waterproof membrane. Budget $500 to $800 depending on your roof type. Flat and low slope roofs are easiest. Steep pitches add complexity and cost. Third is the inverter. You need either a grid tie microinverter or a hybrid inverter if you are pairing the turbine with a battery bank or solar array. Expect $400 to $700 for a unit rated for the Harmony's 1 kilowatt output. Enphase and SMA both make microinverters in that range. Confirm compatibility with the specific voltage and frequency the Harmony produces using the manufacturer's spec sheet. Fourth is the wiring run from the turbine to the inverter, and from the inverter to your breaker panel. Standard outdoor rated conduit and appropriately gauged copper wire. Most residential runs come in under $200. Total lands between $3,500 and $5,000 for a homeowner willing to do the installation work. Before you order anything, answer one question. Does your site have enough wind? The minimum annual average for this turbine to make financial sense is roughly 9 miles per hour. Check your location for free using the Department of Energy's Wind Exchange website, which provides wind resource maps down to the county level. If your house sits in a suburban subdivision surrounded by 2-story homes and mature trees, those obstructions will rob your rooftop of the wind speed the maps promise. Elevation and exposure matter. A hilltop lot or a coastal property will outperform an inland cul-de-sac by a wide margin. Your roof also needs a structural assessment. A spinning rotor in a 30-mile-per-hour wind does not just push down on your roof, it pushes sideways. That lateral thrust transfers directly through the mounting plate into your rafters and top plate. If your roof framing was not designed for that load, you are not installing a turbine. You are installing a very expensive leak. Hire a structural engineer or experienced contractor. A single inspection visit typically costs $150 to $300. The skill level required is honest but manageable. You need basic electrical knowledge, enough to run conduit and wire a dedicated breaker. You need comfort working on a roof with proper fall protection. And you need the patience to read the installation manual cover to cover before you touch a drill. This is not complicated, but it does require that you respect the forces involved. One critical warning: do not substitute cheap, off-brand turbine units that claim similar folding capability. Several manufacturers out of Southeast Asia market turbines with auto-fold blades at half the price. The ones independently tested use plastic pivot bushings instead of machined steel pins. Their spring calibrations are inconsistent from unit to unit. A blade that folds at the wrong wind speed or fails to reopen turns your investment into rooftop debris. The mechanism only works if the tolerances are right. Wind is not equal everywhere, and no turbine changes that. If your property sits in a low wind pocket surrounded by tall trees and neighboring roof lines, the harmony will underperform its rated numbers no matter how well you install it. Suburban lots in sheltered inland valleys are the hardest cases. Vibration is the second reality check. A spinning rotor mounted directly to a building transfers low-frequency oscillation into the structure. Sound levels measured below 45 decibels at 10 feet are quiet, but vibration travels through framing in ways a decibel meter does not capture. Some occupants notice a faint hum inside upper floor rooms, especially at night. Output is the third honest number. At roughly 1 megawatt-hour per year in a decent wind site, this turbine covers about 10 to 15% of an average American household's annual consumption. It is a supplement, not a replacement. Pair it with solar and the combined coverage improves dramatically. Rely on it alone and you will still write a check to your utility every month. The folding mechanism is mechanical, and mechanical parts wear. The pivot pins and return springs need an annual visual inspection and occasional lubrication. Skip that and the blades may fold late or reopen sluggishly. It is a 15-minute job once a year, but it is not optional. A rooftop turbine that stays online through every storm for under $5,000 versus a tower-mounted system at $20,000 that shuts down the moment the weather turns and voids its own warranty if the blades crack. Harmony's folding blades survived 60-mile-per-hour gusts on a residential rooftop in the Netherlands with zero mechanical damage. No conventional rooftop turbine in that price range has matched that claim under independent observation. And that under $5,000 installed cost is what your next energy decision looks like when the machine finally solves the one problem the industry spent a century calling unsolvable. New home technology is coming fast, and most people either buy too early and pay double or wait too long and burn thousands in bills. The Future House files end the guessing. Every technology ranked and timed with the exact price triggers that say, buy now. All worked out on the page, including the 10-year plan that takes an ordinary house from $5,800 a year to zero. Scan the QR code and see it before they sell it to you. So here is my question for you. If you had the budget and the roof space for one addition, would you install a rooftop turbine that folds its blades and keeps generating through the worst weather of the year? Or would you go with rooftop solar panels that produce nothing after dark and nothing during the winter months when your bills peak? Drop your answer in the comments because I genuinely want to know which way you lean. Subscribing and sharing is the single best way to help this channel keep producing the research the mainstream renewable industry would rather you never see. Next week, we are looking at helical vertical axis turbines, the spiral-shaped rotors that pull energy from wind coming at any angle and never need to point into the breeze. That one is going to change how you think about small wind entirely.